Alright, time for another DraftPhysics.com, DebatePhysics.com video presentation. So, another, whatever, Dubai guy comments, and, they're getting lamer and lamer, so there's probably a point where it'll just be time to say, you're just so dishonest, there's no point in having this conversation, because I've already been over so much of this crap. And so there's really just no point, because you're just redundant. Alright, it says, which one do you think is easier, to stop a train or stop a train and make it move in the opposite direction? Which one has the bigger change in motion? Doesn't matter. I could stop a train by putting a bunch of sandbags in its way, and they would absorb all the energy, the momentum. Bowling pins. I could put bowling pins in the way of the train. The train's energy would be absorbed by the pins, the momentum would be conserved perfectly, and the train would stop. Or I could put a spring, right? And that's going to stop the train. Now, it's going to throw the train back because it's storing the energy instead of letting the energy fly into the universe. So the whole point is you don't really believe in reflections. You don't think a reflection is possible in this universe, that a big object can say, I can't absorb your energy. I will not move. Say if we do the train thing, we have a really big train on the Earth, okay? And the Earth can turn. And I put a spring on and I'm going to catch something with the spring. Well, if the Earth turns, I can't load the spring. So the Earth doesn't turn. All right, the spring is loadable because the thing doesn't move, because it doesn't turn, because you haven't given it enough energy to turn it. There's a Planck requirement, a minimum amount of energy you have to be able to hit it with for it to spread that energy and move the whole object. If the whole object can't move, it can't move. That's the rule of elastic, is the whole thing has to go, or you just make a dent, or you break it, or you crack it. But you have to make the whole thing move or nothing. And the point is when it's nothing, that's a reflection. So that's what the anvil's doing. So I brought it up so many times, right? So you're playing this game that somehow you actually believe that every time the ball bearing bounces on top of the anvil, it's putting twice the energy into the anvil. Twice the momentum is moving the Earth, or moving something somewhere. Somewhere that energy is going somewhere, which is nonsense. So you just don't believe in a reflection. But this doesn't change anything. Obviously the spring stores energy, the bowling pins release it. They push it out into the universe, where the spring compresses it inside. So it's like the difference between a spinning disc, right? A spinning disc, you're changing your direction all the time. You're going up and down here, you're going up. Over on this side, you're going down. Complete reversal of your direction. Is there any evidence that it's work? No, the evidence is that it's zero work, because there's a compensating mechanism. So there's no work being done. Changing the direction cost zero. There's zero work being done. The bearing gets more and more efficient because the spin becomes more and more precise, and there's no friction at all if you get up to the higher and higher speeds. So there's nothing. You're not losing anything, and you're completely changing the direction. You could put objects on the disc, and you could shoot one this way and one that way, no problem. You could completely change the direction. So this is bullshit. It's not an argument. It's crap. You don't have any evidence. So again, let's just go say it over and over again. You have no physical experimental evidence demonstrating the collection of kinetic energy. You can't show me it doing work. All right, so he's just such a liar. Anyway, yes, it takes 25 times the fuel to get something to move 5 times as fast. So it's not true. There's physically no evidence. This is just like saying you believe in Jesus. You have no right as a scientifically minded person to say something based entirely on your faith. You have nothing to provide me as reasoning or logic or facts or evidence. It's your faith. I don't give a fuck about your Mohammed, okay? Shove it up your ass, because that's all this is, a religious claim. I've already explained why. You haven't explained shit, so that's just a lie. I use the example of spinning a motor, okay? I didn't say anything about cars and pressure because you're just using this excuse of this more complicated system where you keep converting the energy into different kinds of motion as some excuse when we all know it doesn't take 25 times the gasoline to go 5 times as fast. We know it doesn't. So quit lying that this gasoline engine proves the case somewhere, because it absolutely doesn't. All right, the energy of the fuel pressure, and the pressure pushes the piston. So again, there was no pistons. I said spin a motor, okay, 5 times as fast. I should have said electric motor. All right, the faster the engine runs, the less time there is for the pressure to push the piston and create momentum. So this is all just bullshit. We've been over this crap. You're just such a lying sack of shit to bring this crap up. It has nothing to do with any example. Throwing a baseball doesn't have anything to do with any example on this planet of where I can make something go 5 times as fast. I can flick my finger and move a ball bearing. You have no evidence it takes 25 times the effort to make it move 5 times as fast. It's just absolute shit. All right. So, spinning a top, anything. There's so many examples. The higher speeds means less momentum gained per unit of fuel energy. So again, nonsense. It's actually the distance in the push describes the amount of energy. You probably understand that the distance in the piston moves determines how much the pressure is still left in this cylinder. So again, he's just completely forgetting about the argument and just keep pretending that if I use some complicated system, I can somehow hide the fact that it's 25 times the fuel when it isn't. There's absolutely zero evidence. You have no physical experimental evidence demonstrating any of this crap. So it's just your faith. And frankly, that's unacceptable. All right. If the piston moves only a tiny distance, it doesn't matter how long it takes. Most pressure is still there. It moves a longer distance, we know the pressure goes down. So again, this is just absolute nonsense. Has nothing to do with the fact that you will not put 25 times the fuel in any device, any motor, to 25 times the fuel to make it run 5 times as fast. Just a lie. Okay, so at least we know he's a lying idiot. Okay, and that's probably good reason to just say fuck it. All right. I mean, you can't at minimum just admit you have no evidence of this quadratic increase in fuel requirements. You have no experimental evidence, and the evidence that does exist, like the Mythbuster car crashes, demonstrates no sign of it whatsoever. The ballistic pendulum, no sign of it whatsoever. All right, the bowling ball question is more tricky. Now, there's nothing tricky about it, okay? You're claiming it has twice the capacity to do work. It doesn't have twice the capacity to do work, so why are you calling it energy? If it can't do work, it's not energy. Because I would say both momentum and kinetic energy help knock the pins. So that's just baby talk. So it's a non-answer to the question. So you just evaded the question. I asked a simple question, you evade it with a mush. The math is not that simple, for me at least. What's the math? It's mv squared versus mv. When the ball hits the pin, what is it going to transfer to the pin? Is it going to transfer kinetic energy, or is it going to transfer momentum? And the obvious, already tested answer is it's going to transfer momentum. The ball's going to lose the same amount of momentum it gives the pin. That's what's going to happen, and you know it, I know it. The truth is obvious, and this is just, again, another evasion. You have a problem. Your physics says something that's idiotic and stupid, and you won't account for it. You won't even say, gee, they ought to do the test. Gee, they ought to really find out how much the pins move. And if it's possible for the pins to have twice the momentum, okay, after you hit them. Oh, you people are just such scum. All right. By the way, I already managed to create an animation of a pendulum collision according to physics. So why are you bothering? But okay. If you don't know what happens in the collision, I could use a couple of different cases, both conserving your version of momentum. What are your two best guesses for the 3-to-1 mass ratio? Well, I don't want the 3-to-1. We already know. I'm saying it's 1/4 the speed. So the object hits, 1/4 the speed goes this way, 1/4 the speed goes that way, and then they come back together and 100% bounces back off. So that one's already a given. You say it's 1/2 the speed. I say it's 1/4 the speed. So that one's already known. But just to indulge your bullshit, I did bother. Okay. Oh, that's not going to work. Yeah, well. Let's see. Is there an angle I can put that at? Well, I guess I could rewrite it. So I'll rewrite it. Alright. Because I'm a nice guy. Alright, that should be clear enough to see. Alright, so these are just rough numbers because the tricky part is the 2 mass. I'm not sure about the exact fractional thing. It's not going to be a whole number. It's going to be some less than a whole number. But the argument would be as the 1 mass to the 2 mass, you'd get 15% back of the momentum and 85% would go forward. Something like that. Alright, and then for the 3 mass, it's both have the same velocity, 1/4 the velocity, but it's 25% of the energy is going this way and 75% of the momentum. The momentum is going that way. Alright, and then it goes to 66% for the 4 going that way and 33% the other way. And then 50-50 at the 5 mass, and it's 1/10 of the speed, okay, because it's 5 units of mass. Alright, so that'd be 5/10, 1/2, you know, okay. Then it's at 6, it's 2/3, 66% of the momentum, 33% goes forward. So you're getting less and less into the object, like 1/5 of the velocity. Then it's for 7, it's 3/4 of the velocity coming back. Okay, 75% of the momentum coming back. 25% and 1/20th of the velocity going this way. And by 8 or 9, this is probably 85, not 100. And this is like 15. And then you get to 0. So those are basically the outline of the numbers. Oh, well, I guess I'll leave that a little longer in case you need to write it down. Okay. But yes, you might have to fix those. There's, you know, obviously there'd be linear proportionality in there somewhere. But the trick is getting from 75 to 0 or from 0 to 25. You know, that first notch is not going to be 15%. It's going to be something like 12 or something. Some idiotic number. But anyway, I think that's good enough and such. So we'll call it a video. And just I don't think you've responded at all to the issues raised. Okay, the fact is you have conceded you have absolutely no evidence it takes 25 times the fuel. And to say not force is idiotic. Because the fuel is force. It's completely proportional. You can turn it directly into force. Okay, so it's just idiotic to make some distinction between force and fuel. It's absolute nonsense. The fuel's capacity is defined by how much force it can produce. Megatons, you know. Anyway. So it's just you're just evading the subject, that you have no evidence, and all the evidence, all the experimental evidence points against this nonsense. That's right. You know, we've over it so many times. You haven't responded really. So you evaded the bowling ball question. You evade. I mean, I don't know what the other. There was a third question in there. Yeah, you changed the subject to the animation. There was 3 issues I raised. So what do you think the rocket lifts off? What lifts a rocket off the ground? The momentum of the thrust or the kinetic energy? Is that equal and opposite? Does the kinetic energy produce an equal and opposite reaction? Or does the momentum of the thrust produce all of the motion you get out of the event? And the obvious answer is yes, the momentum. The momentum obeys the 3rd law. Kinetic energy doesn't. Fact. Absolute fact.